my name is Reuven Weintraub. I'm the founder and CTO of Gidel. And what we see is that for some time, getting performance of handling gigapixels per second and more comes to be, in real time, comes to be more and more demanding. And that's per camera, plus need to serve several cameras as well. In general, about Gidel, so we are founded 30 years ago, and our expertise all along was how to do acceleration and image algorithm and vision algorithms on the FPGAs, as well as development tool to enable the full flexibility and performance of the FPGA. What you can see that what we have now for the imaging and vision, we do have frame grabber and image processing from very small ones like 20G interface into over 400 gigabit interfaces per second. We do have very compact FPGA modules that enables to take and put it in your system. And we have a very optimized and compact edge computers. That's from hardware perspective. From software perspective, we do have FPGA development tool to make the development on the FPGA faster, solutions for multi-cameras applications and solutions, and then all kind of compression IPs and other either system or imaging IPs to help you work at gigapixels per second plus. Since not everyone are able to make the designs in the FPGA, we are helping also to tailor solutions in different aspects. It can be just some addition to the hardware, some addition to the IPs, and so on. So that's basically the expertise we have. As I said before, we were doing FPGAs already 30 years ago for the high-end demand. What we see today is that sensor rate are getting faster and faster, whether it is a frame rate faster or resolution or bigger resolution, and the total bandwidth is getting higher and higher. And unfortunately, the PC performance, whether it's CPU, GPU, or AI engines, they're not bridging the gap as fast as the sensors. And therefore, what we see is more and more cases where acceleration is needed and where it's worth using FPGA to accelerate some processing. We see that in different markets, and I want to show here also additional markets to the vision markets. In 3D acting films, you can see around 100 cameras looking outside in to film a scenario, and those will be typically at 60 frames per second and still large pixel size. And then it needs real-time compression, and that depending on the architecture, whether it should be JPEG 264 or 5, or something with higher quality, such as the Quality Plus compression. This is an example. The other example is with augmented reality, moving from the inside out. You have 360 cameras looking at all the around, or sphere cameras looking also up and down. Obviously, in all cases, synchronization of all cameras together are crucial. Then you have all kind of cloud optical inspection that can use many cameras. It can be 10, 15, 25 cameras, sometimes even more. Capturing the data, compressing them, or doing basic analysis, and then sending data to the cloud to be able to do AI inspection in the cloud. In sports, whether it's broadcast or analyze, you have cases where it comes from 4 to 40 cameras with 15 to 65 megapixels, and then still high frame rate. And in that case, in many cases, low latency is also important. And then data goes to the server, and the server decides what to do. So these are just kind of other aspects beside the machine vision. And obviously in the machine vision application, it exists as well. Why to use, or what's needed, and why an FPGA can be used for? So the first question is, performance-wise, what do we need to accomplish a performance? So we do need the processing capability. We need to have enough memory access. We need to have I/O transfer speeds, and in many cases, we need to have low latency. Current FPGA solution we have in our products has more than 100 tera operation per second in a single FPGA. Memory access, there's tens of terabytes per second to the internal memory, and hundreds of gigabytes per second access to DRAM. And that enables a lot of flexibility. And from our perspective, we have solutions starting from 20 gigabit and going up to more than a terabit per second, and obviously the small latency. So the first thing is, today we need to have ability to run application at 1, 2, 4, 5, and more gigapixels per second, and that is crucial. Due to that, and obviously in many cases, low latency is important. In the past, the FPGA had great high-speed performance, low power performance. However, designing with an FPGA is more complex than designing with the CPU. And that is the reason why, if your system is not so demanding and a simple CPU can do the job, just use the simple CPU. But if the FPGA, the sensors and the system requirements are getting higher and higher, then the FPGA can provide advantages. What we focused within our development tools is to have end-to-end solution helping you from the beginning of simulation to test, through testing to deployment, as a full integrated development environment. And our focus is that you will be able to keep optimal the performance and resource usage, and always to be able to add your secret sauce. So our system is an open system that you can add your own sauce inside, or just grab and add different IPs that we can provide, or third parties can provide. As a result, you get much faster time to market for FPGA-based systems. running at full performance and cost sensitive because it's less resources. Hybrid solution. When looking at FPGA acceleration, in many cases, hybrid solution would be the best, not doing everything in the CPU, GPU, or doing everything in the FPGA. And the hybrid solution will take normally using the FPGA to do data reduction. And like in the lecture before, focus not on everything, and you cannot use all the data at high speed and high performance. And then be able to do the synchronization. Unlike in software, in the FPGA, you can have less than a microsecond synchronization, or if you want to synchronize cameras that are apart, a kilometer apart from each other, then it would be a few microseconds just because of the light frequency. And then let the CPU, GPU, and AI engine do the complex designs. I have here several examples. So this is an example, for example, in the traffic control. If you want to have one or many cameras taking images at real time at a high frame rate or reasonable frame rate and high resolution, what can be done is that you can do in the FPGA two streams. One will do a binning and reduce the data, but still see all the image and all the picture. And the other one will do a compression, so the data rate will be smaller. The compression can be stored into the disk, and the CPU, GPU, AI engines can analyze the binning data and select the time critical where someone did a violation or external trigger for violation appears and so on. Then once you do find the time of violation, the CPU can access the disk, get the relevant images, and just blown up the compressed data and see the detailed driver face and plate and things like that. So that's a solution where a good data reduction with an FPGA and sophisticated algorithms run in CPU, GPU, AI. Another example like that can be like in the FPGA to do feature extraction or RI detection, and then store in the FPGA board memory the whole data, and then the CPU, GPU, or AI engine totally can just grab the relevant RI for further investigation. And if needed, you can combine here also a full compression to store if in case of a week later you want to reanalyze something. And this is a kind of recording system. So compression going to the disk, whether online transceivering forward or just an edge computer, and after the few hours of recording, taking data out to the analyzing system. And you can do, again, binning and through CPU display or with multi-cameras to have a control room receiving the multi-images in sample ones. I talked about quality plus compression. We do have all kinds of compression such as JPEG for stills, and we have a lossless compression for people who are afraid to lose anything. And the quality plus compression is the idea is to enable to keep image quality or high image quality and efficient compression ratio by analyzing the image data and deciding that to do the compression not as a generic compression algorithm, but as a compression algorithm that understands something of the data and working accordingly. For that, we are working now on a new version that will be able also to learn on the fly how to do a better compression ratio to the specific scenario that is seen on the spot. And that will be a something that between the lossless compression that has a very good quality and the other compressions that that can do a good compression ratio, but very problematic when you want to do zooming, in some cases of analyzing, stitching, and other algorithms. And that's just an example where we can get all of these capabilities on your hand. So thank you very much. And if you have any questions, you can contact us or feel free to ask questions now.
Thank you, Reuven, for your presentation. I'd start with a question, and maybe in the meantime, our other presenters can come back online for our final Q&A. What compression ratio can be achieved by quality plus compression?
So we're gonna, you can have something like 1:4, 1:5 with the same quality of the original image. And then you can select quality versus compression ratio. And in that case, you'll be able to get still good compression quality at 1:20 and things like that. If your source, for example, is Bayer, then you can still have all your algorithms later analyzing it and not adding additional errors such as the debayering and others.
Okay. Can FPGA process and compress more than a single 100 Gbps camera?
Yes. For example, we have seen cases where tens of cameras need to be compressed at a range of 1 gigapixels per each. And in that case, the system cost about $500,000. And with the FPGAs, with something like, something like 40 cameras of that speed. And with FPGA compression, it can go down to something like 50K only. So it reduces enormously the cost, the power, and simplify the system.
Okay, and we have another question from the audience for you. Which types of the compression do you have in your portfolio?
So currently we have the lossless, the JPEG, and the Quality Plus. We are enabling to use a third party's IPs. In the past, we have delivered the solutions with the 264 with a third party IP.
Okay, thank you.
From our IPs, at least, they're very, very tiny resources using. And the system enables, in many cases, to grab many cameras to a single solution.